What is a bounded input, bounded output, stable system? First thing, very important thing to draw the attention on. Now we are talking about stability of a system. Before we were talking about the stability of an equilibrium. Okay? So we are talking about two different objects. Before we were talking about in the phase portrait, we have an equilibrium. We are discussing about this. Now we have input, output, thingy, and is the stability of the thingy, of the machine. Okay? There are going to be different types of stability. Okay. Let's go here. Let's just to be sure. How would you define a bounded scalar signal? You should have done this one. This is oops. This is the definition. True? True? Let's go graphically. Let's go graphically. I think they're here. This signal here in time, this is bounded. This signal here in time is unbounded. True? Bounded means I'm able to find an M such that for every time I stay inside this tube. Okay? Now, I know there's a relativity. You cannot go faster than speed of light. I know. Okay, let's look at me. V dot equals to BU. I have Voyager 1. And in a certain sense, what am I trying to do? I am trying to do a model that is a very simple model that whenever I fire with my thrusters, I will get a certain acceleration. Together? Perfect. This is an integrator because eventually this is V is equal to the integral of BU. True? Are we together? We call it a single integrator because it's a. If I have an input, so if in time my U, that is my input, is something that looks like this. Is this input bounded? Definitely yes. If Y equals to V is my output, how will the output do? Something like this, true? Is this one going to be bounded? No. This system here is bounded input. There exists at least one bounded input that will cause an unbounded output. Do you see it? Perfect. For this system, is it that every bounded input will produce an unbounded output? No. Why? Because if as an input I take this input here, my output is not going to be bounded, true? Unbounded, true? You see that with this bounded input, my output will be bounded. Together? For this system here, there exists at least one bounded U that produces an unbounded Y, but it's not for every bounded U, okay? There exists. Are we together on this distinction? It's fundamental distinction. We just said it. Let's go fast. Let's go to this. This one is the important part. What do we have? Our single integrator is such that if I take this bounded input in the set of all the inputs and the set of all the bounded inputs, okay, this one is a bounded input and I put it here. If I was taking as an input this signal here, this signal will be here. Are you seeing my drawing? I have the first avocado where I have bounded inputs, all the inputs. That means unbounded inputs. Together? Now, in the first avocado of the inputs, I take this bounded input, and where do I go? I go into an unbounded output. True? But for this bounded input here, I go to a bounded output. I don't know, I do it like this. Like this. You see? Together? Y dot equals to AY plus BU, with A smaller than 0. We are going to see very, very, very soon, we didn't see it yet, but we are going to see it very soon, that the impulse response of this system here, the H of this system here, will look like something like this. An exponential that goes down, sorry. The H is going to be basically BEAT for t bigger than 0 and 0 before, okay? Very often I kind of neglect the t before 0. It's going to be t 0 for t bigger than 0, smaller than 0. If u looks like in time, looks like this signal here. Let me find out. If u looks like this signal here, how do I get the forced response at this time here? How do I get the forced response here? How do I get the output of the system? Given this input, this time, and this impulse response. We saw it last time, yesterday, true? How do we do? Convolution. I take this one, I put it here, I do the multiplication, and I do the integral. This one, true? Is this one, true? This is the input, this is the impulse response, true? Perfect. This is now, the black dot is now. I have the shifted and flipped impulse response, and I have the input all together. And then whenever we do this stuff here, this is the multiplication of the two signals. Together, this violet here is the multiplication of the two signals dot point, and the output is going to be the integral of the stuff here. That means this area here. Together, it's the area. How will the area look like? This is the output. 0, 0, 0, 0, 0, because the multiplication is 0 and the integral is 0. I start getting a little bit of stuff, true? Together, eventually what do I get? The area of the impulse response. Do you see it? Actually, for unitary input, if the input was 2.5, would be 2.5 the area of the impulse response. Together? Are we together with this? This input here, is it bounded? Is it a bounded input, this one? The output, is it bounded? You see that in a certain sense. Whenever I've got this one that is different from 0 or better, this one, that is different from 0 and negative, of course negative, I have a situation for which, for any, you will see very soon, whenever we have A here, this stuff here, anything that I take here, any bounded input is going to bring us to a bounded output. Okay? So we have two systems that are very different. We have a system for which, if I have 0 here, there are some dots here that bring me outside. If this one instead is negative, any signal here brings me here. Are we together? The second system is a bounded input, bounded output stable system in the sense that if I take a bounded input, I am guaranteed to go into a bounded output. And the first one, the integrator, is not BIBO stable because there exists some bounded input that makes me my output unbounded. Would you say that the Dirac delta is bounded? No. Why? Because it's something that has an infinite energy, or better, unitary energy in zero. True? It's kind of a goes to infinity. True? So you are not able to bound it with an end. Okay? Good question. Are we together that delta, the Dirac delta, is not bounded? Dirac delta is not inside here, it's inside here. Okay? So all the potential inputs, all the potential outputs, the inputs that are bounded. Is there something here that leads me outside? If so, BIBO unstable. If not, everything here gets mapped inside here, BIBO stable. Okay? Are we together? Let's make some examples. Ignore this stuff here. I think I've got some. Let's read this stuff here and let's kind of be together on this message before we go. People tend to confuse the two types of stabilities: stability of an equilibrium, stability of a system. Now we are talking about the map from inputs to outputs. Very much together, not at all, kind of. Read and tell me. Questions? Okay. This one you will see later on. It's kind of a more advanced stuff. This one. Would you say that this one is BIBO stable? Yes, no, I do not know. Yes, no, I do not know. Discuss. People, how would you suspect that the impulse response of this stuff looks like? It's an exponential that flies away. So y dot equals to y by itself, the autonomous version is exponentials that escape. True? What is the purpose of the impulse? Whenever I put u equals to Dirac delta, hammers the system and then let it go. But whenever you move something that looks like this from an ODE point of view, as soon as I move from zero, I will escape. True? Are we together? Perfect. If I take this u and an impulse response that looks like the opposite, that goes escapes, I do not know if I don't think that there's an unstable system here, but you got the point that as soon as this one escapes, whenever I do this operation, what do I get? I get something that escapes. True? Is this one BIBO stable? Definitely not. Definitely not. Okay? Is this one BIBO stable? No, for the same reason. Look at this. Is this one an LTI system? Yes, no, I do not know. Definitely not. This is like a bilinear system. There's some product, true? Okay, this is non-LTI. Are we talking about BIBO stability of LTI systems only? No. We can talk about BIBO stability of general systems. Important point, then we come back. Whenever we were drawing the two avocados, avocado of the inputs, avocado of the outputs, were we mentioning linearity or superposition effects? No. Okay? And BIBO stability applies to any system, and we are not confined to LTI systems to talk about BIBO stability of LTI systems. We can talk about BIBO stability of any system. Are we together on this? Perfect. This one, how does it look like? Think at a U that looks like this one. T, a U that looks like this and goes to 0. Whenever it goes to 0, as soon as I've got y dot equal to y, this stuff here, does it explode? Or? Yes. True? You see? I've got U different from 0. No, actually, this is wrong. This is like something like this. As soon as I've got an initial condition that is different from 0, and I've got U equals to 1 that is very bounded, I've got a system that looks like this one that is very unstable. True? The trajectory goes to infinity. I see perplexed faces. No? How much do you feel that we are together, people? Very much? Not at all? Kind of. What perplexes you, people? I see several twos. If I take, ignore this, ignore everything else, ignore this stuff here. The trajectories of a system like this one, whenever y0 is different from 0, are the trajectories of this system here bounded or unbounded? Or you do not know? Unbounded, true? Are we together that they are unbounded? Perfect. If I take this system here and I put u equals to 1, choosing u equals to 1, am I choosing a bounded or unbounded input? U equal to 1 is very much bounded, true? If I take this input here, this one, doesn't it collapse onto this one? U equals to 1, y times 1, y, true? So I take a bounded input and I get a system whose trajectories are unbounded. Is this one BIBO stable? No, because I find. Oh, signore. I find some bounded inputs. This one is this point here that leads me where? To something that is unbounded. Are we together? It's enough that I find one for doing what? For saying this is not BIBO stable. Okay? This one BIBO stable? No, we saw it before. Let's do another question. That is an important one. I have a system. I go to Biltema and I buy a system. And I do one experiment. And I do with one experiment, I put something here. That means I select a U and I get a Y that is bounded. And I did one experiment. Can I conclude that the system is BIBO stable? Why not? Why not? I should do every test because if I find one that brings me outside, then it's not BIBO stable anymore. One experiment is not enough. It's like linearity, true? If I do one test, with one test I've got linear behavior, doesn't mean that it's a linear behavior for every potential test. How much are we together on this, people? 1, 2, 3. Excellent. I love this example here. I love it. I really love it. This one. Is this system BIBO stable? Yes. No. This question has no sense. I do not know. Go, discuss. Okay, people, what would you say? What would you say? I see several trees, and that is the correct one. Here, there's no U, true? We don't have the first avocado. There's only the second avocado. This one doesn't exist. Okay? We cannot talk about BIBO stability. There's no input. Come together. You see it? Question. Okay, so we go back to the definition, to the fact that we need to talk, we need to be together. If I write something like this, for how I interpret it, means that there's no input. If I write it like this and then I say this, is the same as before, true? But the notation means that potentially I might have different inputs, okay? It might be that this one was minus y times u, but u was equal to 1, okay? In that case, we need to discuss and be together. You see the point, people? Excellent, excellent question, excellent question. Now, let's see. It should be sufficiently easy. Go. Great and done. So, people, what would you say? What would you say? If every bounded input leads to a bounded output, okay? Every is key. If there exists one that is not good, then it's unstable. It's similar to situation like this one that we were having with marginal stability. Remember, with marginal stability, we were having this stuff that was looking like this, and one trajectory was going out. True? It was enough for one trajectory to go out to lose the marginal stability. Here's the same. It's enough that we find one that goes out that makes us unstable. Very much together, not at all, kind of together. Excellent.